Hello, this is Robert Miller, and we're going to talk more about multiple regression. All right, so let's go ahead and let's take a look at the multiple regression equation. And we're going to take our time with this and just kind of, get into the flow and go with it and have you have a sense of what's going on in the equation. All right, with special focus on regression coefficients. All right, so here we are. We have y hat, and that's the fancy dressed up y because for each participant in your sample, you have two scores. You have the score on y without the hat, which is the observed score on the outcome variable measure. So that's the score that the person in your sample actually gets on the measure after they take the measure, they complete it, and it's scored by the researcher. And then there's the y with the hat. So I call that the fancy dressed up y, ready to step out in the town and have a hot night. And that is the predicted score for the same participant. Okay, so there's two scores for each participant in your sample. That is the predicted score for the participant on the outcome variable measure from the model. So remember that you always have two scores on the outcome variable measure for each participant in your sample. That score which they actually get on the outcome variable measure after they take it and complete it and they're scored, and then the predicted score on the outcome variable measure for the participant, the same participant, from the model. And that predicted score from the model is based on the participants' scores on the predictor variable measures, which are in the model. Okay? All right, so we're going to work though in terms of y hat. So this is the predicted score for any particular participant in your sample from the model, which contains your predictor variables and each participant's predictor variable measure scores. Okay, so the y hat equals, and then a constant, okay, plus, okay, so here's where we start to have some fun and some things you need to keep in mind. Getting my markers here all ready to rock. So we start with this B sub, meaning the one is, kind of down there a bit, so sub 1, so B sub 1. And that is a regression coefficient or a regression coefficient value. And each predictor variable in your model has its very own regression coefficient value. So let's switch on over now so we can keep these separate and distinct from one another. Here we have x sub 1, and that is your score on your first predictor variable measure. And so these two need to be thought of as being together as a unit. So let's get over to another marker here and go like that. Okay. Okay, so I put that box around them because I want you to think of them as being together, as being connected, being together as a unit. And so for this first predictor variable measure, it has a regression coefficient value related to it or associated with it, connected to it. And what that regression coefficient value tells you about that predictor variable, and more specifically about that predictor variable measure, it tells you about the strength of the relationship as well as the direction of the relationship So about the strength and direction of the relationship between that predictor variable and the outcome variable. Okay? So between that predictor variable measure and that outcome variable measure. Okay, now for the multiple regression equation that I'm going to be talking with you about, we're going to have three predictor variables in the model. Okay? And the model begins right here with the constant, and it's going to go down and include three predictor variables. Okay, so let's go on to the second predictor variable. Switch markers here. Now, you know what's coming next, right? Because everything you need to know about this model, you can learn from just what you see right here. Okay, so here we go. We got B. Now it's sub 2, okay? Because this is the regression coefficient value for the second predictor variable in your model. So x sub 2, and again, just conceptually in your mind, you're not going to actually see this in your regression equation or the model portion of the equation. Here's the entire equation. Whole thing here is the entire equation. Here's the model portion starting with a constant. And you're not going to see this in the depiction of the model, but it's good to keep in your mind, okay, so you can see how this thing is structured. So I want to put another box around these two. So you think of them as being together, okay? And so this is the regression coefficient value for this second predictor variable, telling you what the strength and direction of the relationship is. That's what this regression coefficient value is. It is the strength and direction of the relationship between the second predictor variable and the outcome variable. Okay? Okay, now let's go to our third predictor variable. Now at this point, you can already guess what happens next, right? Because it follows this common pattern. All right? So we go again. And should be no surprise by now what happens next. We have our regression coefficient value. Now for our third predictor variable. All right, and again, we think of them as being together as a unit. And so this regression coefficient value describes the strength and direction of the relationship between this third predictor variable and the outcome variable. Okay? All right, so that's the basic form of our multiple regression equation, starting from here all the way through. End of the model, which starts here with a constant and then goes through our three predictive variables, each with their own regression coefficient value. Okay, so one thing I want you to take note of, you might ask, are these unstandardized regression coefficients or standardized regression coefficients? So depending on what you've read about regression coefficients, you may have at this point heard about both types. You have unstandardized regression coefficients and you have standardized regression coefficients. And how you know which one they are, let's say you're at a conference or you're in class and you just look here, you see this equation up on the board, and you see these regression coefficient values, you may ask yourself, gosh, are those unstandardized or standardized regression coefficient values? Well, how you know which one they are is that if the model includes a constant, okay, so if the model includes a constant, then what that means is that each of these are unstandardized regression coefficient values. And if the constant is not there, if it's absent, so it looks like this, okay, constant is not there, then each of these regression coefficient values are standardized regression coefficient values. Okay. All right, so now let's start adding something here to this. Let's say that y hat represents an outcome variable concerning organizational commitment. Okay, so we'll say org commitment. Okay, and this represents, you get high scores on the measure of this outcome variable. It means someone is very dedicated and just really spends a lot of time and energy working for the company to help it reach its goals and realize its initiatives and the like. And if you have a low score on this outcome variable measure for organizational commitment, what that means is you have someone who's just putting in their time, they finish their job at the end of the day, they go home, and they're really not thinking about anything about just getting their job done and going home and doing everything they need to within their job description, but that's it. Okay, so that's organizational commitment. And we're seeking to predict scores on the organizational commitment outcome variable measure based on person scores on each of these predictor variable measures. All right, and so let's just provide some detail as to what these predictor variables are. Let's say this one is annual department budget. And it's important to note what the predictor variable measure, what units it's measured in. So it's measured in dollars. Okay, so that's our first predictor variable, annual department budget measured in dollars. Our second predictor variable, let's say, is a level of depression of an employee. And the unit here, first of all, this will represent a score on the depression measure, and the unit is a 1 unit change or 1 point change in the score. Let's get rid of that. This is better. Unit is a 1 point change in the score. Okay, so that's our second predictor variable, level of depression, where the unit is a 1 point change in the score. Okay, and then our third predictor variable is round trip commute. Of an employee to work and back, and that's measured in miles. Okay, so this is a common thing with unstandardized regression coefficients, and that is for each of the predictor variables, predictor variable measures, they're measured in different units. Okay, here in dollars, here in 1 point changes in score on the depression measure, and here in miles. And so one thing that this means for unstandardized regression coefficients is that you have to be careful not to compare the regression coefficient values with each other, okay? You might be tempted to. You know, the regression coefficient value here, okay, right here, might be 0.001, and the regression coefficient value here might be 0.15, and the regression coefficient value here might be 1.10, and you might start comparing them and thinking about, well, which one's larger than the other, and you can't do that because the predictive variables are all measured in different units. So these regression coefficient values are not comparable with one another. But what you can do is you can look at a particular regression coefficient value, this unstandardized regression coefficient value, and you can look at values within that regression coefficient value. So, if you say, well, okay, the 0.001, that'd be larger than some other values this could be and smaller than some other values this could be, but you're only looking at it within the particular unstandardized regression coefficient. You're not comparing them with each other. Where you can compare the regression coefficients is when we're talking about standardized regression coefficient values. And it's all standardized according to one particular unit, standard deviation units, and then you can compare the strength of the relationship of each of these predictive variables with each other. But that's only with standardized regression coefficient values, not with these unstandardized regression coefficient values. You cannot be making comparisons between the unstandardized regression coefficient values. Okay, so I have some more things to say about the multiple regression model and in particular the regression coefficients, but that is going to be it for now. So I hope this is helpful, and I'll have more to say to you later. Have a good day.